Chapter 7, Atmospheric Pressure and Wind. Section 7.3, Surface and Upper Air Winds. Winds that occur at the Earth's surface are influenced by the combined effect of three forces: pressure gradient force, Coriolis effect, and friction. Surface winds always begin their flow under the influence of pressure gradient force. Once in motion, the resulting surface wind is then influenced by Coriolis effect. In the northern hemisphere, this effect is to deflect the wind off its path to the right. In the southern hemisphere, the deflection is to the left. Frictional force reduces the strength of pressure gradient force and Coriolis effect. This reduction in pressure gradient force and Coriolis effect causes the wind to blow across the isobars at an angle either towards or away from the pressure center. So it would be towards if it's a low pressure center and away if it's a high pressure center. The next four diagrams will illustrate the formation of a surface wind as it relates to pressure gradient force, Coriolis effect, and friction. So in this first diagram, the wind is just beginning to form, and the main force driving it is pressure gradient force. So the wind wants to blow directly from the high to the low pressure center. The second diagram shows the wind sometime after the first diagram. The wind has already begun its deflection off its course to the right, and frictional effect has begun on this surface wind. A little bit later, we have this situation occurring. So more deflection is occurring, more friction is occurring, and at the same time, the surface wind is slowing down a bit, and Coriolis effect is being reduced. The final diagram shows the resulting wind based on these three forces at the surface. So the wind has been deflected off its course. It's now crossing the isobars at an angle. This angle is anywhere from 10 to 20 degrees over ocean surfaces that have less friction, and over land surfaces with more friction, the angle is between 20 and 45 degrees. So the surface wind is the resulting wind from the balance between pressure gradient force, Coriolis effect, and friction. Surface winds blow clockwise and inward into a surface low, and clockwise and out of a surface high in the northern hemisphere. In the southern hemisphere, surface winds blow clockwise and inward into a surface low, and counterclockwise and outward of a surface high. This is illustrated in this diagram. On the top, we see a low and a high pressure center in the northern hemisphere. So the low is counterclockwise and inward, and the high is clockwise and outward. The bottom diagram shows the southern hemisphere. To the left, we have the low. Notice the direction is the opposite from the northern hemisphere. It's clockwise and inward. And on the right, in the bottom, we have the high pressure center, and it's counterclockwise and outward. Now, upper air winds are only influenced by two forces: pressure gradient force and Coriolis effect. Above 1 kilometer from the Earth's surface, very little friction exists. Upper air winds tend to move parallel to the isobars, and this develops because there is no friction. Winds of this type that are blowing parallel to the isobars are called geostrophic winds. Now, in the upper air, the isobars aren't always straight. We can have the formation of low and high pressure centers. The winds that form moving around either a low or a high, are called gradient winds. So these winds flow either around a high, sometimes called an anticyclone, or a low, known as a cyclone. The wind that blows around curved isobars above this level of friction is, as I said, called a gradient wind. This diagram displays the difference in the pressure, in the forces involved in a surface wind that's located in the bottom of the diagram and an upper air wind. So as we can see, the upper air winds are blowing 90 degrees relative to the pressure gradient force. This diagram illustrates gradient winds for the northern hemisphere. So they blow around a low counterclockwise and parallel to the isobars. And for a high pressure center, they blow clockwise and parallel to the isobars. The direction of flow in the southern hemisphere is the opposite. Clockwise for a low, counterclockwise for a high.